Gary is Director of Engineering and Maintenance at C&W Services. With over 28 years of maintenance, reliability, and construction experience, he has held various roles in increasing responsibility and led maintenance organizations to achieve their goals through the creation and development of key strategies, including condition-based predictive programs, task coordination, reliability-centered maintenance, and planning and scheduling. Under his leadership, the C&W Services Maintenance Organization created and developed key strategies, including condition-based predictive programs, task coordination, reliability-centered maintenance, Lean Six Sigma, and foundational planning and scheduling. Following his service in the United States Marine Corps, he attended North Carolina A&T for construction management and North Carolina State for facilities engineering management. And finally, Gary is a member of Society for Maintenance and Reliability Professionals and is an AMP certified reliability leader. All right, everyone, you're here for predictive maintenance, the baby steps to get big results. Gary, take it away.
Welcome, everybody. I appreciate you taking the time out of your day to listen to this webinar. I'm looking forward to passing some information on to you that's hopefully useful in the future. Okay. The slides to move. There we go. So the first one we'll talk about is, I'll go through the table of contents here and get you to the end. So the first one will be safety. We'll do a safety moment at the beginning. We'll do review some maintenance strategies that most of us should be aware of if you're in the maintenance industry. Then we'll talk about the sensors and gateways. That's how your information gets to your dashboards and those type of things, right? The next one will be monitoring options. Then we'll actually dig into the baby steps and the actual why of condition-based monitoring. So the first one I'll talk about is lockout, tagout, the safety piece, right? This is one near and dear to my heart because I've seen some injuries over the past for poor lockouts, and I've seen some really great lockouts, right? The biggest thing that I always see is lockout, tagout, and they forget the test out piece of that, or the lockout is done improperly. Take the time to apply that lock in the proper and isolate it properly. Our lives depend on it, right? Our most important person we have is our employees. So take that time and protect them and make sure you tag it properly and lock it properly. So first we'll talk about maintenance strategies. The three on the screen here we'll talk about first is the most common strategies you see in the industry. The first one is reactive maintenance. As we all know, reactive maintenance is a run-to-fail strategy, right? So it could be a very expensive strategy for a site. You had to increase your MRO, your parts, because when you have a failure, you have to be able to react to it really quickly. And it also it requires more employees because you have to be able to react and also keep the site running in different locations. The next one that's up here is corrective maintenance, right? Corrective maintenance is actually fixing those failures. It requires a team. They had to be well prepared and equipped. They had to have their tools ready to do that corrective maintenance piece. And the last one, the most important, most common one you see today is the preventive maintenance side. The idea is 80-20, right? 80% preventive and others corrective. Many sites do not reach that in the beginning when they first come out with a preventive maintenance program. It's the most cost-effective program. You actually get to the equipment and you're able to order parts and create corrective measures so that the equipment stays up and running and is available when you need it, right? So unfortunately, less common strategies is condition-based monitoring and predictive maintenance. Condition-based monitoring, the strategy, it focuses on monitoring real-time conditions of the equipment. And also you see condition-based monitoring in rounds where you actually have an employee that goes around and looks at that equipment and measures of decimals or those type of things on that pump or that bearing or that air handler, right? The key aspect for condition-based monitoring is it relies on the data to determine when the maintenance should be necessary. Versus preventive maintenance, you may only see that piece of equipment once a year or once every 6 months or once every 3 months, right? So the condition-based understands where that piece of equipment is presently, and it can notify you if something happens with that piece of equipment prior to it actually failing. The predictive maintenance piece, that's where it uses work order based. It uses your work order system, and it also looks at your condition-based monitoring system, and it gives you an algorithm, right? It tells you what's the probability of that piece of equipment failing within a certain time period. Very tough program to put in place in the beginning, especially if your centralized maintenance management system is not up to date. You don't have your criticality in place. You don't have a good work order system in place. It could be really tough to implement that program at a site. So condition-based monitoring, it's been around since the 1850s, which kind of surprises a lot of people, right? 1850, so it's been around for a very long time. A lot of your programs are developed with the aerospace industry or train industry, right? This one here is with, 1850s. They started took a hammer and would tap on the wheels, and depending on how the sound they received back from the wheel, that would tell them, whether they need to replace, or if there's cracks being found. A high-pitched ring could be a compromised wheel where it's cracked, right? A dull is, if there's cracks, it's dull and flat. So think about that. 1850s, we've had this type of program around. And so as we move from a program, we mentioned, it's been around for a very long time. It's just developed over the years, right? It was moved from a hammer now to where we actually have electronic sensors or different types of collecting equipment to collect that data. There is a tremendous amount of sensors in the market today. A few of them up here, you have vibration, you have motion, you have proximity, you have lighting. Humidity and temperature are the most common ones outside of vibration, using an accelerometer to measure that vibration. You see a lot of critical spaces today. You see a lot of critical spaces like cold boxes and freezers and those type of things. They want to understand that you may have a very low tolerance for those freezers about where and how quick you have to react based off of which products that's stored in those freezers. You do see in a lot of industrial plants today versus the actual hammer, tapping that wheel as we talked about before. A lot of industrial plants are really starting to implement this type of strategy because they see the value of understanding where that equipment is in real time. I have seen a lot of water presence, so that they'll put a water sensor in place to detect water and help, like air handlers, if it's the pan is overflowing and the condensate pan potentially overflowing, those type of things, right? So again, if you look at the screen here, there's a plethora amount of sensors on a market. All these I've used in the past, and they all have their own value about what they can bring to you. So how does the connectivity process for the sensors, and how does it work? That's usually the biggest piece that we have to convince different sites on how to bring this information up. And it's out of fear, right? It's about understanding how this equipment works. The first piece you have is your equipment at the site. The next piece is the sensor, right? The sensor will be attached to it depending on what you're trying to pick up. If it's a bearing, you want an accelerometer so you can understand the difference, when you need to go grease it, or if that bearing is actually moving to failure, to its failure mode in the bathtub curve, right? Also presence sensors, like how many people's in an area. That could determine if I need to bring my air handler up because I have high CO2 in the area, right? Temperature, humidity is common as well. We have a lot of sites that use temperature, humidity because you have an expectation per ASHRAE about those ranges, what the expectation is, or you may have a product in that area that you had to have a specific humidity or temperature range to meet. The great thing is that sensor then will transfer to a gateway, right? If it's an IoT type sensor, it always transfers to a gateway or through the internet, right? Outside of that gateway, it usually bridges and takes that data and gives it it's like a device cloud based, right? So it gets in that cloud, and we're able to create service APIs or device registry from that point. And then on the very last, on the far right hand side here, you see it picks up that data and puts it onto the dashboard for you. Very easy process, very simple process, but it can be very confusing if you don't understand the gateways and IoT and how that works. And that's always the biggest piece when you first start these programs up, is understanding that process and how it works, and connectivity. There's been issues where you put a sensor inside of an air handler, and that air handler is metal, and it's hard to get the information outside of that air handler because it's blocked inside of it. So process map here, it's very simple. It goes from the sensor to the gateway to the IoT cloud, and gives you a visualization on a dashboard, and it lets you know where your state of management is on that piece of equipment for that sensor. So, monitor options, right? There's a lot of different dashboards that you can use today. My last check, I found over 40 different type of dashboards, ranging from Power BI to actual sites like Fluke or Pedisense or UE. Has those dashboards you can build out, and it's similar to what you see on the screen here today, where it can tell you your kilowatts. It can do sustainability measures for energy. Particular sites we manage, and energy is a big piece of that for sustainability, right? We want to make sure that we understand what they're using, how much water is coming in, and what their energy use is for that day, and how we can reduce that carbon footprint at that site to make them more profitable moving forward. Extremely important. The second piece of the dashboard you see up here is a utilities dashboard. That may be measuring a pump, or it may be measuring a bearing, may be measuring temperature of that bearing. We've had many different variations from, I've set up so many sites of different types of sensors that there's a tremendous amount of options for a dashboard and how you want it to view to different people. You can set it up to higher level management. Can see a certain piece of it. They maybe only want to see energy, to where your utilities or your actual technicians may want to see the vibration and current data or those type of things, right? Here's an example of a pump being condition monitored, right? So often you'll see a sensor installed on the motor, front and back, depending on the size. If it's below 25 horsepower, do you need one on front and back? That's depending on the site and your process that you set up in place. The next piece, you have your Lovejoys or your connections for your pump. You may need one on that. You may need one on the flow to understand how much flow is coming outside of that pump in case you have a cavitation issue or a flow issue. And you can pick that up prior to having a failure downstream when you're monitoring. Right? This is a simple SCADA type pump dashboard. So we're at the baby steps, right? That's a piece I really wanted to spend a lot of time on. I went through the original small stuff that you should be aware of at the sites. So the baby steps are very, very simple. And I always say, for us in our company, we talk about process, performance, and people, right? If you don't have the process, the people and performance are really going to struggle. So the very first thing I always tell anybody is create that process. Identify your critical equipment. It may require you to do an FMEA. It may require you to stop and look at that equipment and see if it's really critical, because oftentimes when you're going through your site, you may find that you think a piece of equipment is critical, but there's a tremendous amount of redundancy to back that equipment up when you're doing your FMEA or your follow-up information. So identify that critical equipment, right? The next piece is pick 1 to 3 pieces to install those sensors on. I often recommend starting with something that's not critical. Remember, it's a new program, right? Your employees have to understand how it's used, what it's measuring, and they're learning as well. So the worst thing you can do is put on a critical piece of equipment and it fails because the employee didn't understand the system or a process that you put in place because of training. So once you get the process in place, again, the next piece is people, right? Condition-based monitoring is a tool for the people. So it's a tool for us to understand on how to drive efficiency, making sure that a piece of equipment really is available when you need it. Very critical, right? So recommending you pick 1 to 3 pieces and identify the sensors. It may be a simple motion sensor for it, so you can identify occupancy. So you may want to lubricate the doors more often because you have a lot of door failures in the space. What about current or your amp draw? Those are very key for your sustainability for the site. You don't want to miss those. The incoming power to the site can be really critical as far as how much you use per day and how much you want to reduce that carbon footprint for the site. I've also seen light meters, right? So if I measure the looms in the space, I may be able to dim my lights and reduce the amount of energy I use for that site. So those are 2 things, right? At the very beginning. The last one is the staff. Remember, people, process, and performance, right? So if you want to train your staff, you want to make sure you don't want to go put a sensor in place and then not have the staff to understand on how to read those sensors and what to do with them. It's extremely important to make sure you train them on your process that you're identifying, and they're involved in that process to deliver it for that critical step, right? That person is a make or break person for you. When they're installing these sensors and they're identifying an equipment, they need to make sure that they're heavily involved in that startup process for condition-based monitoring. Those baby steps are extremely important to follow because of the potential failures and the loss of the program, and go back to the old way of run to fail or preventive maintenance, right? You really want to move your site to that more modern approach to be successful. I like to identify low-hanging fruit. It may be a pump, that nagging pump that it's always failing, and it may be in a critical area or not in a critical area. It's nice to have the data to show somebody that, hey, I got high vibration in 2 or 3 different areas, and I need to work on this pump before it shuts you down. So low-hanging fruit is the simple ones, right? There's something that's always nagging you, something that's always bothering you. They can really give you big benefits in the front side to show the program to be successful, right? Picking up that vibration or bearing, lubricating it before it fails can make a big difference. The other one, you see a picture here of a cooling tower, right? That state-of-the-art cooling tower that everybody has, and many sites don't, right? I've seen sites that had wooden towers before. That you need to understand that fan starts to vibrate, and that fan takes 6 to 8 weeks to get back into stock. You want to save that fan or that motor or that pump or that cooling tower because it's so critical for your chillers, right? That may be a place you want to install it in the beginning. The other key thing is make sure your equipment's in good state before you install those sensors. You want to start off with a good state of vibration before you put a sensor up there and not understand how to get back down to a good state, right? Air handlers. Again, low-hanging fruit, right? There's so many places to install a sensor on an air handler. It could be filters. You're measuring your filters, so you're in a high dirty air, a high dust content area, and you got to replace the filters more often before you have a THP issue, a temperature, humidity, or pressure issue. Or it could be installed on the actual motor itself for belt vibration before a belt fails, a V-belt, right? The fan bearings or the pressure sensor down from the back side of that for the going into the rooms. So there's a tremendous amount of opportunity as far as installing a simple sensor or one sensor on a piece of equipment on an air handler that can give you big dividends in the front side when you're finished with it. Example here, so we also often talk about why do we want to move from predictive maintenance to, from preventive maintenance to predictive maintenance. The probability of missing it is 70%. If you go to it today, within 6 months, there's a high chance of it failing because you're not in front of it. You don't understand it. You don't hear it. You don't see it at the site. You know, the picture here you see it's 9 days before the failure. Look at 4 days before the failure. How quick it moves up, right? It almost in 2 days it goes to failure mode immediately and shuts down. So your probability of missing that actual failure is very high with preventive maintenance because it depends on your frequency of visits. The second piece of that is back up there. So the second piece is the 80% of your failures are caused by touching, right? You touch it too much or not enough. So just keep that in mind when you're looking at condition-based monitoring. Sometimes, you know, it's like a light switch. The more you operate it, higher chance of failure because you're moving it back and forth, which causes fatigue and failure in the long run. This side here, just some places where we've installed sensors in the past and we've caught really quick failures prior to them failing. We were able to stop the problem just by, you see here on this air handler, we had a high vibration. We went and greased. It needed grease. We identified it needed grease. We went and greased that air handler or that bearing. Saved that bearing. That bearing was about right at $2,000, and it would have shut that air handler down for about a day to replace it. So very, very nice to have that. That vibration sensor on there before we actually had a complete failure and had to shut the unit down completely for 2 days. The next one you see here is we kept coming into this space and it was hot in the mornings. And we're like, well, why does it keep getting hot in the area? On the building management system, it says running 100% of the time. Come to find out, there was a schedule on that system that was shutting that air handler down at nighttime for a few hours, which causes condensation on the walls in that space because it shut down for so long. And it was kind of hidden in the building management system where you couldn't find that actual schedule. So the vibration sensor actually told us that, look, here's what's happening, right? You may need to adjust your schedule so you're not getting that condensation on the wall. And then the far right one is an air handler that needed a belt alignment. We installed those sensors and it immediately picked up that there was vibration on the belt. It needed to be tightened and aligned, laser aligned to eliminate that, right? So stopping from having to replace the sheaves, which is more expensive than a belt in the long run, or the shifts, excuse me, in the long run. So here's the why, right? Comprehensive equipment monitoring. Remember, you want to monitor that equipment so you understand where it's at. In between those preventive maintenance, the potential of missing that failure, as I mentioned in the slide, 2 slides before, is about 70%, right? Effective cost utilization. You want to make sure that you're using, how many times does the site grow and get bigger, and you can't hire more employees to do that, right? The advantage of condition-based monitoring is you can restructure your team and put your condition-based monitoring on high critical areas or just high critical equipment and utilize your team in different areas versus preventive maintenance. And that keeps them going to the equipment when it's actually needing something done versus looking at it to see if something's done, right? There are substantial maintenance benefits for condition-based monitoring. What about filters, right? I've seen sites where I've started measuring filters, differential pressure, and instead of replacing them every 3 months, because I have a high flow MERV 14 filter on there, 13 filter on there, I don't have to replace it for a full year because I'm measuring now based off of loading versus before I was actually going and replacing it, even though it may not have needed it, right? I mentioned this a minute ago, improve employee utilization. I can move those employees around to different areas and get them, get the site more successful and be more visible versus actually trying to go figure out if something's wrong. Condition-based monitoring lets me know that there is something wrong when I go to it, right? And last, 70 to 80% of your failures are caused by people. We actually make those problems for ourselves. Not tightening a wire nut when we check the voltage. Taking the hoses off of the compressor and releasing a bunch of refrigerant when I don't need to actually check it there, right? at that time because I check it so often, I lose a lot of refrigerant from it. That was short and sweet, right? It's baby steps, and I made sure that this presentation was about baby steps. I wanted to make sure you understood that 3 simple steps can really do a lot for you. Remember, process, process, process. Keep that process in place to make your site successful. So, any questions?
Gary, we do have some questions. And for those that are on the line, if you'd like to ask Gary a question, please be sure to enter your questions in the question section, and we'll get to as many questions as we possibly can. So Gary, if you're ready, I'll go ahead and get started.
Yep, I'm ready.
The very first one is, how do you think AI will change the future of condition-based and predictive maintenance?
So for me, it's I think AI is very powerful. It's a very powerful tool, but I don't think we understand it yet. I think we're moving so fast that that I think it's going to be a struggle to get into places. If you think about the condition-based monitoring, that started in 1850s, and we still don't have it at 100% of our sites. So I think AI is great. I think it will change the overall picture, but I think it's going to take some time to get to where we need to be at.
Thank you. And the next question I have, sorry, they're coming in pretty quickly. I want to stretch out my questions and make sure I can get the full information. Okay. The next question. Can we start predictive while 80% of maintenance activities are corrective?
That's a great question, and that's always the struggle. And as I mentioned in the slides a minute ago, you can definitely start it. The key is if you're at corrective now, if you jump immediately to predictive, you have to understand that you want to make sure that equipment's in a good state before you install those sensors or those type of condition-based monitoring, right? It could be very dangerous just to go up and what I mean by dangerous is it could be detrimental to a program if you go up and put on a piece of equipment that's already it's moved into the bathtub curve and it's high predictive to failure, right? So you don't want to move too quick in that program. Get it in a good state, and I think you can definitely move to condition-based monitoring and predictive maintenance for sure.
Thank you. And the next question is, can you address the optimum sampling rates of sensors versus the cost of storing data in the cloud?
That's a tough one, right? The sampling rate depends on that piece of equipment. Also depends on the criticality of the piece of equipment. Do you need to store it for a full year, or do you just need to store it for 6 months? Often depends on what type of piece of equipment it is, right? So that's a really tough question. I've often used based off of criticality. So if it's an extremely critical piece of equipment, I may want to look at it every hour, right, or every 10 minutes. If I have a lot of failures in that piece of equipment in the past, I may increase it or decrease it, depending on what I see when I first start that piece of equipment up. For me, I often do, when I start that predictive maintenance up on that piece of equipment, I may start it to pick up the data every 5 minutes, do a reading every 5 minutes. And after 2 to 3 weeks or even a month, I may change that to every hour because I'm not getting a lot of data from it, right? So that would be my recommendation.
All right, next question. How can condition monitoring sensors improve the daily routes and equipment performance validation?
That's a wonderful question. So routes oftentimes are to go look at the piece of equipment, where condition-based monitoring is already looking at that piece of equipment. So as a question before mentioned, how often should we measure that equipment? If you have a route that's every hour, you put that sensor on it and it's already measuring it every hour, then that reduces the amount of time you have to spend on routes, and you can redistribute your labor to a different location. Routes is very expensive because definitely needed it, especially in the utilities world. But it depends on what you're looking at and how you're looking at that equipment for those routes. But that would be my go-to.
Gary, the next question, ask a question and then gives 3 answers and asking for your opinion. So it
Okay.
says, on what basis should the selection of equipment be? Criticality, cost of maintenance, or more time in maintenance?
So I am always based off criticality. And the reason I say that is what brings financial gain to the company, and that's your most critical pieces of equipment. So I always start with the critical piece of equipment first. In the beginning, I do a very simple, non-critical piece of equipment, and then once my employees are comfortable, I move them to the critical type of equipment.
All right, next question, and they're still coming in. Can we connect sensors from different manufacturers to the same alarm system and dashboard?
That's a wonderful question. And those options are there. You just have to understand those pieces of equipment and how they work in the gateways. So yes and no, depending on if it's an open network versus non-open network.
All right, next question. What is your recommendation in the case where internet is not available on site?
Perfect. So there is cellular networks that you can put in place to monitor those pieces of equipment. There is also, you can move to start the program up just to get some wins. You can use round type process to where those rounds are actually doing condition-based monitoring and picking up that data for like lubrication using an ultrasonic type process to do that. So I would recommend using a cellular network if you do not have internet presently at the site.
All right, next question. Maintenance is key on a regular basis to prevent bigger problems. Any thoughts?
Maintenance is key. Can you just repeat the question for me, please?
Yeah, it says maintenance is key on a regular basis to prevent bigger problems. Any thoughts?
I would agree to that maintenance is definitely key. As the site ages, right, your maintenance increases, and oftentimes companies try to decrease that depending on the location. And the way around that is to use condition-based monitoring, right? So you understand where it's at. So maintenance is absolutely key, and you got to have it. Depends on how you use that maintenance to be successful at the site. Is up to your management team for sure.
All right, next question. Sensor efficiency is by the environment the sensors are exposed to. What are the features that are there to ensure correct information from the sensors in different environments?
So there's two options, right? So often, if it's in a high critical area, and if it's IQ, OQ type stuff, right, for pharmaceutical or food manufacturing, oftentimes you put those sensors on a calibration program. So I can go and calibrate that sensor based off of that area. So I'll go calibrate a sensor, put a calibrated sensor next to it, and make sure I'm getting good readings back. You know, if it's temperature, humidity, air monitoring, those type of things. So a good calibration program really makes a difference there.
All right, next question. Any thoughts about remote monitoring systems?
Remote monitoring systems. So essentially, that's what condition-based monitoring is remote monitoring, right? To where you understand what your equipment's doing right now and what state it's in. So I'm a little confused on the question.
Okay, we'll move on to the next question. What are some expensive ways to begin to build a predictive maintenance system?
The most inexpensive way to begin building that system is picking out one piece of equipment and starting with, if it's not vibration, it may be, like I said, the filters. Once you get the wins off of filters from an air handler, that shows value, and you can redistribute that money. Instead of replacing the filters, you can buy vibration, right? Then you can start adding your temperature, humidity type sensors. So the most inexpensive method for me would be to start those three areas.
All right, next question. Where is the best place to start a new condition-based monitoring program?
So I always start with non-critical. It's a brand new team. I put my process in place. Then I train that team, and I put sensors on a non-critical piece of equipment to let them learn and understand how those sensors react. Then I'm going to move to critical from there.
All right, next question. In your opinion, what holds companies back from the condition-based monitoring maintenance strategy?
There's two pieces to that. So first one is understanding the change in strategy. The industry's always heard about preventive maintenance and reactive maintenance, but oftentimes they've bypassed the condition-based piece of it. And the second one is return on investment. Oftentimes your managers or your people implementing the process don't know how to explain that return on investment, what it can do for the site. With our company, we do it often. We do those type of things often with the sites and help them understand what the return on investment can be by utilizing condition-based monitoring, for sure.
All right. And if anyone has any questions, now's the time to get them in. I see a few more bouncing in right now, so I'll jump on those. I was going to say I have my last question, but I have 3 more questions, Gary. So okay. Thank you for your patience.
Of course.
All right. On our next question, on a startup project, how do I get my vendors who are doing FMEAs and suggesting control measures like maintenance tasks, how do I get them to consider CBM more seriously?
There's 2 approaches to that. I'll explain the first one and then go into the second one. So the first one, many of your industries, your equipment is actually being sold with those sensors already on it. A good example of that is your iAlert is being sold with the Gould's type pumps, or your Marley cooling towers. They already have vibration on it. You just had to tie it into a system, right? And so the manufacturer understands that it's critical for success for that piece of equipment. And that'd be my recommendation, is letting them understand that the manufacturer is recommending it. The industry is moving to it. We have to create that process to be successful at that site. The second option, right, is it's really tough. Project management is very simple. On time and under budget, and you're successful, right? Often at the end, condition-based monitoring is dropped out. So you have 2 options: either create preventive maintenance for that piece of equipment to be successful, or the condition-based. And very often, unfortunately, it's moved to the preventive maintenance side because they're trying to save money at the end of the project. Just critical to make sure you're in those meetings for commissioning and understanding where they're at with their budget, and trying to get that equipment ordered early in that project management process versus late would definitely help out.
All right, I have a short question and then a long question. So we'll go with the short question first. Okay. What is your opinion on ultrasonic grease guns?
I love them. I think it's an absolute one of the best things on the market. It's really, oftentimes we see employees go out and over lubricate, where you have seals failed and you had to replace a bearing, which causes downtime. The ultrasonic greasing takes that away. It lets me know how many decimals I'm at. If I put a half a squirt in, I can listen and understand how much grease is going into it, so I don't over grease that bearing or under grease it. So I think it's an absolute excellent process for any site to use.
All right, and the promised long question. Sounds like you have a lot of experience in many different industries. What is the highest number of sensors and the type you have installed at a site?
It's a long question. So yes, I have a lot of experience from pharmaceutical to paper pulp to aluminum manufacturing. So to answer that, it's roughly over 350 sensors at one site, measuring various from steam, steam traps to vibration to temperature to -80 freezers all at one site. A lot of critical stuff, right? If I lose steam, it can cause me problems. So, including amp draw, I measure that, and differential pressure. So that's probably the best answer I could give you as far as how many sensors and stuff I've installed at the site and the types. Air monitoring is definitely, if you think about COVID, air monitoring has definitely been on a high rise as far as how often we should check it and what type of sensors we need to put in place. So,
All right.
hope that answers.
Yeah, thank you. I have another question that came in. How do you suggest consolidating your multiple PDM programs into an overall asset health score or metric?
Overall score or metric?
Yeah.
So there's a couple. There's actually one option I'd recommend is understanding that equipment and your failures, where they're at and how you're going to measure them, identifying your measuring points and how you're going to share that data to your executive team going forward. So if someone wants to, whoever asked that question would like to reach out to me after the call, I'd be glad to go into more detail about that one.
All right, thank you, Gary. That was, oh, wait a minute, there might be another one that just came in. I'm sorry, it was a quick question for me. All right, Gary, thank you so much for your time again. Thank you for another amazing presentation and giving us your time. You always have so much information to share with our participants. And to the audience, thank you for joining us today.